Let the noise of the day fall away for a moment, because what we're about to dive into isn't just another curious object drifting through the vastness of space. It's something different, something unsettling, something that forces us, not gently but insistently, to confront the edge between what we know and what we only think we know. Every era of human history has had its moment when the universe seemed to lean in and whisper, "Pay attention." For us, that whisper has a name. 3i Atlas. At first glance, it was just another interstellar visitor, another silent wanderer crossing the solar system, destined to be photographed, dissected, categorized, and eventually forgotten. But then the images arrived, razor-thin lines of light stretching across the black, so impossibly straight, so stubbornly perfect, that astronomers around the world found themselves staring at their screens with a single shared thought. This cannot be real, because in the ordinary universe, the universe we teach in classrooms, simulate in labs, and rely on to keep the sky predictable, nothing behaves like this. Jets of vapor do not carve million-kilometer needles through space without bending. Rotating bodies do not paint straight lines. And nature, for all her creativity, does not rewrite physics on Tuesday mornings without warning. So you sit there, watching those images, and a strange feeling creeps in. Not fear, not yet, something quieter. A kind of cognitive dissonance, the mind trying to stretch around a shape it wasn't designed to hold. It begins with the simplest question: how? How can a body spinning once every 16 hours produce streams of material that refuse to curve, refuse to smear, refuse to obey the gentle geometry of rotation? If you've ever watched a garden sprinkler turn in slow motion, you know exactly what should happen. The water draws spirals, arcs, beautiful curves marking each turn. But 3i Atlas does none of this. Its jets remain as straight as surgical incisions, unwavering, pure. Imagine that. Material erupting into space at hundreds of meters per second, travelling 1,000,000 kilometers or more, and somehow maintaining a direction so stable that it makes a laser look imprecise. You begin to feel the first spark of wonder, and right behind it, the first tremor of unease. Because anomalies happen, but not like this. Not with such defiance, not with such intention. You think back to the first time you learned about comets, asteroids, the clockwork precision of gravity. You were taught that the universe is indifferent, cold, mechanical, nothing personal, nothing deliberate. Everything governed by equations so reliable that entire civilizations could depend on them. But what do you do when something stops following the equations? What do you do when the universe stops acting like the universe? As the images circulate, researchers run their early calculations. 5 exposures, 3-minute stacks, 2 telescopes, independent observers, clean data, no artifacts, no smears, no irregularities. The conclusion is as unavoidable as it is uncomfortable. The jets are real. The straightness is real. The contradiction is real. And suddenly, we're no longer just observing a visitor. We're observing a violation. So you lean in, closer than before. Not because you want answers, but because you can feel the moment demanding something from you. Awareness, presence, humility. You sense that whatever this object is, whatever story it carries across interstellar darkness, it is not simply passing by, it is performing. And that is where the unease deepens, because performance implies behavior. Behavior implies pattern. and pattern can imply purpose. You notice that the scientists who speak publicly choose their words with surgical caution. They emphasize uncertainty. They emphasize the need for more data. They emphasize, above all, the responsibility to remain grounded. But behind their voices, behind the practiced calm, there is a tension they can't quite hide. A collective realization. If this phenomenon is natural, it is unlike anything we have ever recorded. And if it isn't natural, the implications will echo far beyond astronomy. You begin to imagine the moment humanity truly understands what it's seeing. Will it feel like revelation, or like a boundary breaking? Will it feel like an answer, or like the beginning of a far more complicated question? Because straitjets are not just visually striking, they are symbolically confrontational. They cut across space like declarations, like lines drawn with intent, lines that say, "Look again," lines that say, "You are missing something important," lines that say, "Wake up." And maybe that is why the images hold us so tightly. Not because they are beautiful, though they are, not because they are mysterious, though they certainly are, but because they challenge the quiet assumption we rarely speak out loud, that we have, more or less, figured out how the cosmos works. 3i Atlas leans down from the dark and whispers, "No, you haven't." And so here we are, suspended between awe and apprehension, staring at an object that shouldn't behave the way it does, unraveling a puzzle that shouldn't exist, trying to reconcile the universe we thought we understood with the one unfolding right in front of us. If these jets are a message, then perhaps this is the first word in a language we have not yet learned to translate. If they are a coincidence, then it is the most exquisite coincidence nature has ever crafted. And if they are something else, something engineered, then we are standing at the edge of a revelation big enough to reshape not only our science, but our sense of place in the cosmos itself. Whatever the truth is, it begins here, with a line so straight, so impossible, that all we can do is follow it. Where it leads, we're about to discover. When the first images of 3i Atlas began circulating within small corners of the astronomical community, they didn't arrive with the thunder of a breaking headline or the drama of an emergency broadcast. They arrived quietly, almost shyly, as if the universe itself were testing whether humanity was truly paying attention. At first, they were just another set of deep exposures, the kind professional observers share among themselves, sent from one private inbox to another. A whisper passed between people who spend their lives trying to catch a glimpse of the extraordinary in a sky that rarely offers anything more than incremental surprises. But this time, the surprise did not hide in subtle curves or faint traces or clever mathematical deductions. It stood boldly in the center of the frame, undeniable even in raw form. Two thin, impossibly straight filaments of light slicing across the black, so precise and unwavering, they looked more like deliberate strokes on a canvas than natural features captured by a telescope. Those who first opened the files didn't gasp or shout. Instead, many reported the same reaction. They blinked, leaned forward, and assumed something must be wrong with their screens. They checked the calibration, they checked the software, they checked the stacking process, they checked everything except the possibility that the universe had drawn something so geometrically perfect that even seasoned astrophotographers doubted their own eyes. Yet the more they checked, the clearer the truth became. The images were clean. The sensors were stable. The exposures were long enough to rule out noise, vibration, atmospheric distortions, or any of the usual suspects that normally plague deep sky imaging. There were no trembling pixels, no compression artifacts, no digital ghosts pretending to be cosmic structures. The jets were real, and so a quiet tension spread among the observers, a feeling that something significant was unfolding, not loudly, but with the calm certainty of a tide rising in the dark. This wasn't a comet with the usual halo of dust, the messy plume, the uneven scatter of material that tells the familiar story of ice and heat and solar wind. This was different. The lines were too thin, too sharp, too stable. They did not flare outward or fluctuate in brightness. They extended like spokes from a wheel, each one maintaining its orientation with an almost arrogant indifference to the rotation of the nucleus beneath it. Imagine the patience required to stare at such an image, knowing that every instinct trained over years in the field is telling you that something has gone off script. Normally, a discovery begins with an explanation. With Atlas, the explanation was absent. There was only the image, stark, elegant, and frustrating in its refusal to disclose how it came to exist. Observers compared notes, shared early interpretations, and tried to fit the phenomenon into familiar categories, but none of them fit. This wasn't a debris trail. This wasn't a sensor defect. This wasn't a comet tail distorted by magnetic fields. It wasn't an ion plume behaving strangely. It wasn't anything that had a place in the lexicon of cometary dynamics. The strangest part was that the longer they looked at the images, the more unsettling they became. It wasn't just the straightness of the jets, it was their confidence. They looked like structures that knew where they were supposed to go. They didn't meander or fade or spread as they extended across hundreds of thousands of kilometers. They remained coherent, almost disciplined, as if some unseen principle were guiding their shape. For a brief moment, many astronomers privately entertained the same forbidden thought, the thought they would never dare publish in a paper or even mention out loud in a conference hall. Jets do not do this. Not by themselves, not naturally. But the mind quickly reeled itself back in. Astronomy is not built on fantasies. It is built on data, and data demands patience. Still, even patience doesn't erase the feeling that something is off when nature begins drawing straight lines in a place where only spirals should exist. As more exposures were collected, the story grew stranger. Different nights, different telescopes, different weather, different observers, yet the jets stayed the same, perfectly straight, perfectly aligned, perfectly indifferent to the rotation period of roughly 16 hours that should have twisted them into spiraling ribbons. 1,000,000 kilometers, 40+ rotations, zero curvature, zero deviation, zero compliance with the expectations of physics as we have always known them. There is a moment in every scientific mystery when denial ends and attention sharpens. That moment arrived as the images continued to pile up, each one reinforcing the last, each one whispering that this was not an anomaly to be dismissed, but a message to be deciphered. The observers began to realize that they were not merely documenting a strange comet. They were witnessing a phenomenon that demanded a new framework of understanding. Something about these jets was deliberate in appearance, not necessarily in origin, but in the way they projected certainty and stability across distances that would normally shred any structure into chaos. The emotional impact of such images is difficult to describe unless you have experienced it yourself. The sensation of knowing you are looking at something that should not be possible, and yet it is right there, pixel by pixel, clean and uncompromising. You feel your internal model of the universe flexing under the weight of evidence, not breaking, not collapsing, but stretching toward a truth that has not yet revealed its full shape. And while the scientific mind races to find a rational foothold, the human mind drifts into territory. It doesn't always admit to exploring territory filled with questions that feel too large, too primal, too audacious. Questions like, what force could maintain such precision? What mechanism could suppress rotational distortion? Are we witnessing a mistake in our understanding of nature, or the signature of something else entirely? But those questions, as enormous as they are, do not appear all at once. Instead, they arrive slowly, like footsteps approaching through fog, each one carrying a little more weight than the last. And as they arrive, the realization grows stronger. Whatever is happening out there, in the cold silence beyond Mars, it is not something we can ignore. The images are calling for attention, not just from scientists, but from anyone who has ever looked up and wondered whether the universe is truly as empty as it sometimes feels. In the stillness of those early nights, as observers compared their data and calibrated their instruments again and again just to be sure, a quiet consensus formed, not stated, not formalized, but felt. Something extraordinary was unfolding in the dark. Something that might force us to reconsider not just how comets behave, but how the universe communicates with us through phenomena we are only beginning to understand. And whether this communication is accidental or intentional is a question that lingers like a faint echo across those impossibly straight lines of light, waiting patiently for humanity to catch up. The deeper scientists dug into the geometry of the jets, the more unsettling the picture became. Not because the calculations were complicated, they weren't. In fact, that was the most disturbing part of all. The math was simple, almost insultingly straightforward, the kind of back-of-the-notebook calculation every undergraduate astrophysics student learns in their first year. If a rotating body ejects material at high speed, the path of that material forms a curve. Not a maybe, not a sometimes. A curve is guaranteed because rotation always imprints itself onto the motion of whatever escapes from the surface. It doesn't matter if you're dealing with a water sprinkler on Earth or a chunk of ice venting gas in the vacuum of interplanetary space. The principle is universal. Yet here stood 3I Atlas, a spinning object throwing out jets at roughly 400 meters per second. And the results were lines so straight they might as well have been drawn with a ruler across the void. Imagine watching a tiny world, barely dozens of meters across, complete a rotation every 16 hours. Imagine the jets it produces firing continuously for days, their material drifting outward, accumulating distance, piling up millions of kilometers of thin glowing structure like the strokes of an invisible pen. During that time, as the jets extend, the nucleus rotates again and again, 40 times, 50 times, each rotation theoretically shifting the origin point of the outflow. Each rotation should carve a new layer of curvature into the jet's shape. And yet, none of it happens. The jets remain straight. The angles remain fixed. The outflow aligns itself with a direction that does not change. It is as if the rotation does not exist. To grasp how shocking this is, picture yourself observing a lighthouse beam sweeping across the ocean. If that lighthouse somehow projected a long trail of mist that retained its shape, you would expect the trail to arc and twist as the lighthouse rotated. Now imagine that trail instead stretching out across dozens of kilometers with no hint of curvature, staying perfectly pointed in a single direction while the tower beneath it turns. You would not mistake that for a natural process. You would assume something else. Some mechanism unknown to you was anchoring that beam in place. That is precisely the confusion scientists faced when examining Atlas's jets. The physical expectations were childishly simple. The jets should curve. The reality was childishly stubborn. The jets refused. And if the expected geometry fails, then the expected explanation collapses with it. So researchers began to check everything again: rotational period, composition, velocity distribution, thermal models, even the possibility of unknown constraints within the nucleus's surface. But every variable only reinforced the conclusion. Under known physics, straight lines of this length are impossible. Still, science does not accept impossibility lightly. It tests every assumption, challenges every conclusion. And so came the questions: could the nucleus have slowed dramatically since the last measured rotation? Could the jets be so weak or so intermittent that curvature fails to accumulate? Could the material be heavier, more cohesive, or interacting with solar wind in some unprecedented way? None of these attempts survived scrutiny. A slowing rotation would require a braking force orders of magnitude stronger than outgassing can provide. Weak jets would not appear razor-thin across 1,000,000 kilometers. Heavier material would disperse faster, not slower. Solar wind cannot straighten jets that should be curved from the moment they leave the surface. Every explanation crumbled. And then the most uncomfortable thought of all emerged, not because it was wild or dramatic, but because it was calm, logical, and quietly devastating. What if the jets are not responding to the nucleus's rotation because something is countering that rotation? What if the outflow direction is being stabilized, anchored, maintained, as if held in place by a mechanism that corrects orientation in real time? In engineering, this concept is not exotic. Spacecraft use it, probes use it, even satellites use it. Reaction control thrusters fire in specific directions to maintain stability against torque. Small bursts, tiny corrections, gentle but precise. The idea is simple. If you want a jet to stay pointed in the same direction while the body beneath it rotates, you apply counter-torque. You nullify the spin. You hold the vector steady. Of course, applying this principle to a natural interstellar object sounds absurd. And yet, when the data so clearly mirrors the behavior of stabilization systems we ourselves design, the mind cannot help but wander into forbidden territory. Not because we want the universe to contain intentional structures, but because the universe is presenting a pattern we cannot easily dismiss. But even before the technological implications arise, the jets themselves are already forcing a deeper question. What are we really seeing here? A failure of our understanding of cometary physics. A new class of interstellar objects with unknown internal processes? A natural phenomenon behaving with unnatural precision? Or something else entirely? Something that does not yet fit into our vocabulary? The unsettling part is that the jets do not simply extend straight. They extend confidently. They extend with an indifference to rotation, with a stability that should not belong to a fragile, volatile object shedding material in the harsh sunlight of the inner solar system. They extend with the quiet discipline of a structure governed by rules we have not yet uncovered. You can almost feel the weight of this contradiction pressing against the boundaries of established knowledge. It is not that the jets break physics, it is that they obey a physics we have not yet mapped. Perhaps there is a natural explanation waiting to be discovered, hiding in some overlooked property of interstellar ice, or structural cohesion, or non-Newtonian outflow behavior under extreme temperature gradients. Perhaps these straight jets are the first clue of a new category of cosmic processes. Or perhaps they are the footprints of something built, not born, something designed to behave with intention. But whatever the truth is, the geometry refuses to be ignored. It stands there, stark against the black, daring us to understand it. And as we continue to stare at those long, unwavering lines of light, we begin to realize that they are more than just features of a distant object. They are a boundary marker, an invitation to step beyond familiar models, to follow the evidence wherever it leads, even if the destination reshapes our understanding of what the universe is capable of. The jets stretch outward like questions too large to ask all at once, and the rotation of the nucleus spins quietly beneath them, ignored, overridden, or irrelevant. And somewhere between those two motions, the stubborn straightness of the jets and the gentle turning of the body below, something extraordinary is happening, something we are only beginning to comprehend. As scientists confronted the stubborn geometry of the jets, they naturally turned toward the explanations that had always served them in moments of confusion. In science, the first rule is simple. Before you invoke the extraordinary, exhaust the ordinary. And so the attempts began. One hypothesis after another, each grounded in the mechanics of comets and interstellar bodies as we've understood them for decades. The initial proposal was almost reflexive. Perhaps the rotation had slowed. If the nucleus of 3I Atlas had experienced significant deceleration between its last measured spin period and the moment the images were captured, the curvature one would expect from the jets could have diminished. But the deeper analysts went, the more apparent it became that this idea was not simply unlikely, it was backwards. Sublimation rarely slows a comet's rotation, it accelerates it. Jets behave like thrusters. They carve momentum into the nucleus, spinning it faster, not calming it into gentle stillness. For Atlas's rotation to have slowed enough to erase the curvature entirely, the braking force would need to be ferocious violent enough to disrupt or even tear apart the nucleus. Yet the object appears intact, undisturbed, almost serene. The theory collapses under its own weight. Still, researchers persisted. They suggested that perhaps the jets were triggered only at specific rotational positions, firing in pulses when certain shadowed cavities briefly caught sunlight. In theory, this could produce discrete bursts instead of a continuous spiral. But nature leaves clues when it works in pulses. Each burst should form a bead along the length of the Jeter sequence of bright, evenly spaced segments separated by predictable distances. And given the measured rotation period, those beads should number in the 40s. The images reveal none. No beads, no segmentation, no rhythmic pattern. Only continuous, unbroken streams of material extending beyond the frame. The precision of the jets contradicts the very fragmentation this hypothesis depends on. So researchers went further. They proposed that perhaps the jets were not jets at all, but the lingering traces of fragments ejected long ago, the stretched, fading remains of a violent breakup episode. This idea felt tempting, if only because it avoided confronting the jet geometry directly. But again, the evidence interfered. Images from earlier dates show the nucleus as a single coherent structure, not a cluster of fragments dispersing in different directions. If a catastrophic breakup had created those linear trails, the debris field would be obvious. The jets would not align, they would not remain thin, and they certainly would not stretch in multiple stable orientations simultaneously. A fragmentation event can explain chaos. It cannot explain order. At this point, the explanations grew quieter, more strained, more desperate. Scientists asked whether unknown thermal conditions could cause asymmetric outflows that mimic linear structures. Maybe invisible surface geometries were funneling gas along narrow paths. Maybe a unique chemical mixture was responsible. Maybe the nucleus had internal chambers acting like nozzles. But every attempt to reconcile the phenomenon with known physics spiraled back to the same unshakable contradiction. The jets do not behave like passive responses to heat. They behave like active structures maintaining orientation despite rotation. And that simple fact sits at the center of the mystery, refusing to be smoothed over with conventional reasoning. There is a point in scientific investigation where the familiar tools become hammers, striking glass forceful, determined, but ultimately unable to shape the material in front of them. That point arrived quickly, not because the community lacked creativity, but because the observations themselves were too precise, too disciplined, too resistant to naturalistic explanations. The jets weren't wild or chaotic. They weren't sculpted by chance. They weren't fluctuating. They were unwavering, consistent, and elegantly simple in a way that felt almost confrontational. Nature can be beautiful, but rarely is she this tidy. And so, reluctantly, researchers began to look at the hypotheses that no one ever wants to reach, not because they are sensational, but because they sit on the thin line between humility and fear. They asked whether perhaps a principle was at work that we had not yet discovered. A new kind of outgassing behavior. A novel structural property of interstellar objects. Something that could anchor the jets against rotational influence without invoking anything beyond natural physics. But even these attempts faltered. The more models they built, the more simulations they ran, the clearer it became that any natural mechanism capable of producing such perfectly straight jets across such astronomical distances would itself be revolutionary. Something so far beyond our current understanding that invoking it would be nearly as bold as invoking the unthinkable. And yet, there is value in approaching the unthinkable, not to embrace it, but to map the boundaries around it. When researchers quietly, cautiously compared the jet behavior to the behavior of spacecraft stabilization jets, they were not being dramatic. They were simply doing what scientists do, identifying patterns. If you show an engineer a phenomenon that suppresses rotation, maintains orientation, and produces stable linear exhaust, they will recognize it immediately. It's the signature of counter-torque. It's what you design when you want something to stay aligned, no matter how its body turns beneath it. And while no one in the scientific community is ready to declare that 3I Atlas behaves like a vessel, the uncomfortable truth is that the comparison fits the observable data far better than any naturalistic explanation currently on the table. This is where caution becomes essential. Not to avoid speculation, but to avoid hubris. Before humanity can accept the possibility of something engineered, it must eliminate every natural explanation. Not because we fear the extraordinary, but because we respect the method that has carried us this far. Still, there is a kind of tension that arises when the universe presents a phenomenon that mirrors technology. a tension between what we can explain and what we can only observe. And even though no one wants to arrive at the conclusion too quickly, the data pushes inexorably in that direction. The jets behave as if they are controlled, as if their direction matters, as if orientation is not a consequence of rotation, but something maintained independently of it. But before the mind leaps to conclusions, it must consider an even more important question. Why would the universe give us something so disciplined, so deliberately precise, if it were purely natural? What purpose would such behavior serve in the cold mechanics of interstellar drift? When nature behaves strangely, we learn. But when nature behaves with precision typically associated with intention, the lesson becomes harder to discern. Perhaps this is a clue of something fundamental, a new principle hidden in the physics of volatile material under exotic interstellar conditions. Perhaps this is the beginning of a discovery that will reshape comet science for a century. Or perhaps the jets are revealing something else entirely, a design we do not understand, a mechanism we cannot see, a behavior that hints at something beyond the familiar. No one claims certainty. No one claims revelation. Yet the silence around these jets is not the silence of ignorance. It is the silence of people standing at the edge of something larger than their current vocabulary allows. And in that silence lies the quiet understanding that the search for natural explanations is not just a duty, it is an act of protection, shielding humanity from conclusions it is not yet ready to hold. But as each explanation falls away, as each hypothesis collapses under the weight of the evidence, the space around the phenomenon becomes emptier, clearer, and more unforgiving. And in that widening space, one question begins to take shape with a clarity no one expected. If nature did not guide these lines, then what did? As the familiar explanations collapsed one after another, a subtle shift began to take place in the tone of the scientific discussions surrounding 3I Atlas. It wasn't dramatic, and it wasn't public. It was the quiet shift that happens when minds trained to resist speculation start to acknowledge that the remaining possibilities are no longer fitting comfortably within the domain of natural processes. No one wanted to say it out loud, but everyone could feel the boundary approaching. The moment when the conversation would have to include the hypothesis that breaks the unwritten rule of astronomy: never assume intention where randomness could exist. Yet the jets of Atlas were beginning to violate that rule, not because they declared intention, but because they imitated the behaviors associated with it so convincingly that ignoring the similarity felt like closing one's eyes in front of the evidence. And that is where the idea of thruster-like behavior emerged, not as a declaration, not as a claim, but as an observation that could no longer be avoided. The jets of Atlas behaved like controlled outflows, directionally stable, resistant to rotational influence, unwavering across distances that should have magnified every imperfection. In human engineering, this is the domain of reaction control systems, those small but essential mechanisms that stabilize satellites, guide probes, and maintain precise attitudes during flight. These systems work by firing tiny bursts of gas against a craft's rotation, holding a vector steady even as the body turns beneath it. And when astronomers familiar with such principles looked at the data, they recognized a pattern that matched too neatly to ignore. The jets of Atlas were acting like orientation-holding structures, behaving as if their direction was not a product of rotation, but something preserved against it. This comparison unsettled many researchers, not because it implied alien design, but because it introduced a question with no comfortable answer. If these jets are counteracting rotation, then what mechanism, natural or otherwise, is responsible? The scientific instinct is to assume nature first every time, even when the path grows narrow. But nature rarely produces phenomena that are both stable and directional with this level of precision. Randomness tends to spread and diffuse. Turbulence creeps in. Structural irregularities assert themselves. Everything bends, twists, or frays under enough distance and time. But Atlas's jets did none of these things. They remained slender, unwavering, deliberate in their orientation, defying the natural tendency toward disorder. Some scientists attempted to find solace in the hope that perhaps the forces involved were simply misunderstood, that maybe some unrecognized internal geometry could create an outflow so aligned that it mimicked controlled behavior. But even those most inclined toward conservative explanations felt the tension rise. For such a natural system to exist, it would need to exhibit a level of internal structural precision unprecedented in any known interstellar object. Cavities perfectly aligned, pressure balanced with extraordinary delicacy, processes capable of stabilizing jets across rotational cycles through sheer coincidence. The odds stacked against this grew so astronomically steep that invoking such a model felt more like forcing reality to comply with comfort than following evidence to its logical conclusion. And yet, no one wanted to cross the threshold prematurely. No one wanted to lend their voice to a narrative that humanity is not yet prepared to hold responsibly. The history of science is filled with moments where extraordinary claims leapt ahead of data and left confusion in their wake. So the community did what it always does when standing at the edge of the unknown. It stepped back, breathed, and returned to first principles. But even first principles offered no refuge here. Rotation produces curvature. Outflow produces diffusion. Distance amplifies imperfections. Time magnifies irregularities. Atlas ignored all of these. It held its orientation with a stubbornness that resembled intention, even if none existed. And that is where the philosophical dimension quietly emerged, because when the behavior of a phenomenon resembles purpose, even if no purpose is there, the human mind begins to ask questions it would rather avoid. Not sensational questions about visitors or messages or intelligence. Those are distractions. The real question is far simpler, yet far heavier. What are the limits of natural processes? And what happens when a phenomenon lands precisely on the boundary between natural and engineered behavior? If nature can produce something that mimics control this convincingly, then what else might we be missing? And if nature cannot, then what principle, what mechanism, what structure, what unknown domain of physics has sculpted this object into its current form? The more the discussions evolved, the clearer it became that this was not about aliens, or technology, or speculation. It was about the responsibility to acknowledge that the universe is offering something unfamiliar, something unwilling to fit into established categories. And in that unfamiliarity lies the courage required to admit uncertainty. Because sometimes the extraordinary is not a dramatic revelation. Sometimes it is a quiet, persistent defiance of the rules we thought were universal. A reminder that the cosmos is under no obligation to remain within the boundaries of our comfort. And perhaps that is the most unsettling part. The jets of Atlas do not announce anything. They do not flare or pulse or signal. They simply exist straight, stable, patient. A phenomenon that behaves with the elegance of design whether or not design is truly there. And as humanity stares at those lines carved across the dark, we are left with a feeling that is not fear, not excitement, but something deeper. The awareness that we are observing a process that refuses to explain itself. And so the question remains suspended, hovering in the silence between possibilities. If these jets hold their direction because something stabilizes them, then what exactly is doing the stabilizing? As astronomers expanded their investigation beyond the impossible straightness of the jets, they discovered that this phenomenon was not an isolated curiosity, but rather the latest entry in a growing catalogue of irregularities surrounding 3I Atlas, an evolving pattern of contradictions that refuse to fit into any known template of cometary behaviour. Like chapters in a story the universe had begun writing long before it reached our solar system, each anomaly carried its own unsettling weight, and together they formed a mosaic of evidence pointing towards something far more complex than a simple interstellar visitor. It became clear that the straight jets were not the beginning of the mystery. They were the 12th reflection of a deeper truth the object carried with it. A truth whispered across light curves, chemical spectra, orbital mechanics, and the strange geometry of its activity. And as scientists began piecing these fragments together, the picture that emerged was not the illustration of a typical comet, but something behaving as if it existed at the margins of our understanding. The first hints of oddity appeared long before the jets. They emerged in Atlas's trajectory, the path it carved through the solar system as it approached and then retreated from the sun. Interstellar objects are, by definition, wanderers, arriving from random vectors, indifferent to the architecture of our planetary system. Yet Atlas did something unusual. Its incoming trajectory aligned with the orbital plane of several planets, with a probability so small that many dismissed it as a coincidence. Perhaps it was, but coincidences of this scale do not pass unnoticed. The alignment was precise enough to raise eyebrows among orbital dynamicists, who noted quietly that such trajectories often require a story behind them, a long history of gravitational interactions or an origin condition that allows for such improbable precision. Atlas carried none of those stories. It simply arrived, following a path too neatly woven into our plane of planets for comfort. Then came its activity. Comets behave predictably near the sun. They brighten as ice sublimates, then settle into a plateau before fading. Atlas broke this pattern. It brightened too rapidly, as if something beneath its surface was being exposed suddenly or activated by a mechanism unrelated to mere heating. The acceleration of its activity resembled a trigger rather than a gradual process, leading scientists to wonder if internal pressures or structural compositions were more exotic than expected. Yet even this did not fully account for the rate at which its luminosity spiked. Something inside Atlas responded to solar proximity with an aggression unseen in typical interstellar objects. The chemical composition of its emissions deepened the confusion. Spectroscopic analysis revealed an unusually low water content far below what comets typically exhibit. Instead, the object emitted a plume suspiciously rich in nickel. Not the soft glow of dust, not the evaporation of frozen volatiles, but metals associated with industrial alloys here on Earth. Science does not jump to conclusions, but patterns are patterns, and nickel-rich outflows hint at thermal environments or structural properties that do not match ice-dominant comet models. Naturally, researchers proposed alternatives. Maybe the object lost its water during interstellar transit. Maybe it originated from a dry environment. Maybe collisions or cosmic ray exposure altered its composition. But these explanations, while theoretically possible, did not fully address the intensity, purity, or persistence of the nickel emissions. It was as if the object carried something resembling refined materials, something resisting easy categorization. Then came polarization measurements. When sunlight reflects off a comet's coma, the scattered light becomes polarized to a degree that helps determine grain size and distribution. Atlas defied this too. The polarization was not merely unusual, it was extreme, deeper and darker than any known comet observed under similar conditions. The coma absorbed light in a way that suggested structural irregularities or materials that did not match standard dust models. The readings resembled those sometimes found in artificial surfaces, things with smoother microstructures or less random alignment. Yet again, the scientific community stepped cautiously, unwilling to ascribe meaning where none had been proven. But the data lingered, stubborn and opaque. Perhaps one of the most whispered anomalies was the direction Atlas came from. Not simply the interstellar void, but a region loosely associated with the direction of the 1977 WOW signal, the unexplained radio burst that fueled decades of speculation. This correlation meant nothing on its own. Space is vast, and coincidences occur. But in a narrative already thick with improbabilities, it settled into place like another strange echo of something unresolved. Another anomaly emerged from Atlas's motion, its non-gravitational acceleration. Many comets experience slight deviations in their trajectories caused by outgassing, but Atlas accelerated in a way that required approximately 13% mass loss, according to standard sublimation models. Yet the object did not fragment. It did not shed visible mass. It did not exhibit the chaotic behavior typical of bodies undergoing major loss events. Instead, its acceleration looked steady, smooth, almost controlled, as if whatever pushed it did so with meticulous balance rather than random sublimation storms. Then there was the anti-Talon effect, where dust aligns toward the sun instead of away from it. Atlas displayed this phenomenon with a clarity and frequency that defied expectations. Anti-tails are rare, typically requiring specific geometric alignments and finely tuned dust distributions. Atlas produced them repeatedly, across differing observation windows, as if its internal processes were generating material in orientations that naturally favored such structures. This again raised the question, was Atlas simply an outlier with exceedingly unusual internal dynamics? Or did it possess a systematic behavior disguised as cometary activity because that was the only language our instruments were able to speak? The brightness fluctuations offered yet another puzzle. Instead of behaving smoothly, its luminosity spiked abruptly, then settled with an eerie regularity. These surges weren't random. They followed patterns reminiscent of systems undergoing phase shifts or discrete transitions, like a machine turning on segments of its operation, or a structure revealing different layers as it rotates or heats. Natural bodies can behave erratically, but this was too clean, too modular. Then came the coma morphology. The dust envelope formed shapes that refused to comply with standard fluid dynamics. Instead of diffusing outward in smooth gradients, it revealed sharp edges, knife-like separations, and angled divisions that looked engineered rather than sculpted by solar wind. These edges persisted, shaping the envelope into faint geometric signatures that suggested stability rather than turbulence. and perhaps the most philosophically jarring anomaly, occurred when observers cross-referenced the timeline of Atlas's approach. The object's arrival and perihelion passage lined up so precisely with multiple planetary positions that calculations suggested a near improbable synchronization one that served no obvious natural purpose. If Atlas were a probe, this synchronization would fuel theories about gravitational assists or observational windows. If it were natural, it represented a cosmic coincidence so perfect that even stoic orbital dynamicists felt a quiet unease. Finally came the anomaly that tied everything together: the jets. Straight lines extending for 1,000,000 kilometers with no curvature, ignoring rotation completely. The 12th anomaly, the one that broke the silence and forced the community to acknowledge that the universe had placed before us a phenomenon that demanded more than incremental hypotheses. The jets did not just complete the pattern, they revealed it. A structure that refuses to smear under rotation is one that behaves as if locked to an internal axis, a stabilized orientation, a behavior that nature seldom offers with this level of precision. Yet the most haunting part of these anomalies is not their existence, it is their coherence. Each one could be dismissed in isolation. Each one could be rationalized, debated, softened by alternative models. But together they form a sequence, a constellation of evidence suggesting that Atlas is not merely unusual, but systematically divergent from expectations. It is not a single deviation. It is a chain of deviations, not random, not chaotic, but interlocked, patterned, almost narrative in their progression. And so the scientific community finds itself in a rare moment of shared humility. Not the humility of defeat, but the humility of recognition that the universe has handed us something that does not fit. Something that may force us to expand the boundaries of what we consider natural. Something that may require new models, new physics, or new ways of interpreting structures traveling between the stars. Whether Atlas is a relic of a foreign environment, a remnant of an unknown cosmic process, or something crafted by principles we do not yet understand, the weight of the evidence demands openness, not sensationalism, not fear, but openness, the willingness to follow the data beyond the comfort of established assumptions. Because in the end, the 12 anomalies of 3I Atlas are not merely scientific puzzles. They are a message encoded not in language, but in behavior. A message written across the darkness of interstellar space in patterns of motion, composition, brightness, and geometry. And while we do not yet know what that message means, we can feel its gravity pulling us forward, urging us to look deeper, to question more boldly, and to accept that understanding may lie beyond the horizon of the models we have always trusted. The jets point outward as if showing us a direction. The trajectory whispers of intention or extraordinary coincidence. The composition hints at processes unseen. The brightness patterns pulse with quiet purpose. And the entire structure of the object moves through our solar system like a riddle in motion. A riddle that does not ask for belief, only attention. And perhaps that is what Atlas brings, above all else. Not answers, but a reminder that answers are sometimes less important than the willingness to look without fear, to listen without bias, to recognize that the universe is not constrained by what we expect of it, and that sometimes an anomaly is not an error, but an invitation. As the 12th anomaly settled into the collective awareness of astronomers, a new kind of anticipation began to grow. Quiet at first, then steadily spreading across observatories, research groups, and the hidden corners of scientific forums where professionals exchange theories before they harden into papers. It was the anticipation of data yet to come, the awareness that the universe was not finished speaking. Atlas had slipped behind the glare of the sun for a time, forcing humanity into a kind of cosmic intermission, a pause in which speculation could thrive, but certainty could not. Yet everyone understood that this pause would not last. The object was moving, shifting into a new position relative to Earth, and within weeks it would once again emerge into clear view. When it did, the next wave of measurements would not be just another chapter, they would be the test. The moment where the universe either confirmed our deepest suspicions or gently pulled us back toward more familiar explanations. In that sense, the waiting became its own kind of scientific ritual, a collective holding of breath. Observatories prepared their instruments. Data analysts refined their algorithms. Teams rehearsed their protocols, adjusting exposure times, calibrations, spectral resolution settings, and tracker precision, knowing that even the smallest improvement could mean the difference between missing a detail and capturing the clue that changed everything. For all the complexity surrounding Atlas, the next stage was brutally simple. Observe, measure, compare, and accept whatever the heavens revealed. One of the most anticipated datasets was the updated light curve. If the object's brightness followed patterns closer to those of natural comets as it re-emerged, the community could tentatively lean toward explanations rooted in revised physics. But if the erratic spikes returned, if the object once again brightened not gradually, but abruptly, as though awakening in discrete phases, then the puzzle would deepen. These fluctuations carry fingerprints. They tell stories of processes happening beneath the surface, of internal mechanisms or structural transitions. Natural comets breathe in long, slow rhythms. They wake in gentle gradients. Atlas did neither, so scientists waited to see which rhythm it would choose next. Beyond brightness, the rotation period needed remeasurement. If the nucleus had genuinely slowed or sped up, that alone could hint at forces shaping its behavior. Yet the key was consistency. A stable rotation period would force the jets back into focus. How could outflows remain straight if the body beneath them kept turning? But a shift in rotation could open the door to more nuanced models. Researchers prepared to analyze subtle variations, micro changes in spin, the kind that could reveal whether internal mass was redistributing or whether torque was being applied by forces we had underestimated. But even here, predictions were uneasy. Atlas had already defied expectations in ways that made traditional forecasts feel fragile. The next crucial metric was jet morphology. If the jets remained straight, unwavering, and aligned across million-kilometre spans despite additional rotation cycles, then the natural explanations would begin to dissolve completely. It would mean the behaviour was not a transient fluke, but a stable feature, a law unto itself. Yet if the jets began to curve, if even a slight arc appeared, then nature might reclaim the narrative. Curvature would be a bridge back to the models we trusted, offering comfort to those who feared the implications of perfect straightness. But many suspected that the jets would not change. Patterns as stark as these rarely vanish. They reveal themselves more clearly each time they are observed. Spectral analysis promised to be another battleground of interpretation. If the nickel-rich emissions persisted, or evolved, or intensified, then scientists would confront the uncomfortable truth that materials associated with high-temperature environments were being ejected in ways that did not match the thermal profiles expected for a body like Atlas. If water content remained low, the case for an ordinary comet would weaken even further. And if new elements emerged, elements that suggested refinement, processing, or unusual chemical separations, then the scientific community would have to consider possibilities that strayed far beyond conventional comet models. Trajectory refinement was on the list as well. Even the slightest non-gravitational acceleration, if measured precisely enough, could rewrite everything. A small deviation, consistently maintained, could imply active control. A drift too smooth to arise from random outgassing could push the phenomenon into territory humanity has never formally acknowledged in astrophysical literature. But if the trajectory aligned perfectly with predictions, if the object behaved with the passivity expected of natural bodies, then the extraordinary claims would lose their foundation. This single dataset had the power to either erode the mystery or crown it. And finally, high-resolution imaging loomed as the ultimate arbiter. If the nucleus fractured, if debris appeared, if the jets widened or collapsed into spirals, then the mystery could soften into something manageable, something that fit into the known history of volatile objects. But if the nucleus held steady, if it remained intact, symmetrical, and emitting those impossibly straight jets, then the scientific landscape would shift. Not violently, not sensationally, but profoundly. Because a natural object maintaining orientation-stable outflows that ignore rotation would hint at processes we do not yet understand, or perhaps mechanisms we have only seen in the devices we build ourselves. And so, the community waited. But the waiting was not stillness, and it was preparation. It was the sharpening of tools and the clearing of intellectual ground for whatever truth would arrive next. The atmosphere felt like the moment before an eclipse, when the world dims just enough for the mind to register that something enormous is about to pass across the sky. There is no fear in that moment, only gravity, a recognition that knowledge is approaching, that ignorance is thinning, that understanding is near enough to touch. Atlas would soon step out from behind the sun, and when it did, the sky would speak again. Whether it whispered reassurance or deepened the enigma, no one could say. But everyone understood that the next observations would define the story, shape the narrative, and perhaps reveal whether this object was a rogue natural wanderer performing miracles of physics, or something else entirely, something shaped by principles and forces we are only beginning to sense through its behavior. And within that coming confrontation between data and expectation, a quiet truth lingered. The universe rarely allows mysteries to remain half-revealed. Sooner or later, it forces the disclosure. And for Atlas, that moment was drawing near, like a shadow sliding across the sky toward the edge of revelation. As the world waited for Atlas to return to view, the conversation gradually shifted from what the object is to what it means. Because somewhere between the 12 anomalies, the impossible jets, the strange acceleration, and the chemical signatures that defied cometary logic, humanity found itself confronting a question far larger than the identity of a single interstellar traveler. The question was not whether Atlas was natural or artificial. The question was what either possibility would imply about us, our understanding of the universe, our expectations of cosmic order, and our place in the vast intelligence or indifference that surrounds us. And as these implications rippled through scientific circles, philosophical discussions, and private thoughts alike, a new realization settled in. The mystery of Atlas was not just astrophysical, it was existential. If Atlas is natural, then the universe is stranger, more inventive, and more capable of creating complex structures than we ever suspected. A natural explanation would mean our models of cometary dynamics are incomplete, that the chemistry of interstellar bodies is more diverse than we imagined, and that the processes shaping distant regions of the galaxy operate with an elegance we have yet to witness directly. In that scenario, Atlas becomes a messenger from a deeper level of physics evidence that nature can sculpt precision where we expect chaos, stability where we predict disorder. And this alone would be revolutionary. It would force us to rewrite our textbooks, recalibrate our expectations, and accept that our definitions of natural and possible were simply too small. But if the alternative is true, if Atlas is not a random wanderer, not a passive relic of cold cosmic geology, but a structure shaped by intention, then the implications reach further than any scientific paper can comfortably explore. Because intention is not a property of rocks or ice or dust. Intention is a property of minds. And while no scientist would ever declare such a conclusion without overwhelming evidence, the mere possibility reshapes the landscape of meaning. Not in a dramatic, sensationalist way, but in the quiet shift that happens when a boundary long considered absolute begins to blur. Yet even the hint of such a possibility forces us to consider consequences that reach far beyond the confines of academia. It forces us to imagine how humanity might react if confronted with evidence of engineering not born on Earth. Would nations cooperate to study the object? Would governments compete, fearing that understanding might yield advantage? Would religious communities see signs of creation or apocalypse? Would the public respond with wonder or dread or disbelief? We have no precedent for such a moment. We have no handbook. The closest analogues' first contact with new civilizations on Earth reveal both the best and the worst in human nature. Curiosity, fear, conflict, unity. And although Atlas offers no message, no communication, no intent we can decode, the psychological impact of simply acknowledging its possibility would resonate through every layer of society. But perhaps the most profound implication is not socio-political, it is personal. Because when you look at those impossibly straight jets, maintaining their orientation across 1 million kilometers, ignoring rotation as if rotation were irrelevant, you feel something beyond scientific curiosity. You feel perspective. You feel the weight of being a species that only recently learned to step beyond its own atmosphere. Suddenly confronted with a structure or a phenomenon that seems to exist on a higher rung of the cosmic ladder. Whether the explanation is natural or technological, Atlas forces us to acknowledge how young we are, how early in our evolution, how limited our senses, our tools, our frameworks. And in that humility lies not fear, but a strange, uplifting clarity, that the universe is not small, not predictable, not domesticated. It is still wild, still mysterious, still filled with frontiers we have not even begun to imagine. If Atlas turns out to be purely natural, then humanity will celebrate the discovery of a new category of interstellar object structures that behave with a precision we previously believed impossible. It would mean that the universe has mechanisms capable of producing astonishingly ordered phenomena without consciousness behind them. It would mean that nature itself is more alien than any extraterrestrial intelligence could ever be. And that revelation would make the cosmos feel larger, deeper, more intricate. But if Atlas reveals something else, if the jets remain straight, if the acceleration remains controlled, if the chemical anomalies persist, and the structure continues to behave with the steadiness of design, then humanity will face a different kind of truth. Not a frightening one, not a cinematic one, but a philosophical one. That intelligence might not be unique to Earth, that we may not be the first or the only or the most advanced, that somewhere beyond the thin bubble of our atmosphere, other minds may have risen, thought, built, and left artifacts drifting between the stars. Yet this realization does not diminish us. It enlarges us. It reminds us that life, in its deepest form, is not a miracle unique to one planet, but a possibility written into the fabric of the cosmos. And whether Atlas is natural or artificial, its presence tells a story of complexity, of evolution, of processes unfolding across distances and timescales far above our own. It reminds us that our understanding is in its infancy, that we are still at the dawn of awareness, that the night sky we inherited is not a silent emptiness, but a library whose books we are only now learning how to read. And so we wait not just for data but for meaning, not just to measure Atlas, but to understand ourselves through its reflection. Because in the 12 anomalies, the impossible jets, the mysterious trajectory, and the strange chemistry, the universe is not merely showing us something unusual. It is reminding us that discovery is not a destination, it is a direction. And Atlas points the way. As humanity stood on the threshold of understanding Atlas, a deeper and more delicate question emerged, one that reached beyond physics or astronomy into the psychological fabric of our species. It was the question of how we, in all our complexity, would respond to a revelation that either expands the boundaries of nature or hints at intelligence beyond our own. And to grasp that question, you must first imagine the moment humanity acknowledges what Atlas represents. Not the scientific acknowledgement captured in research papers or conference presentations, but the collective emotional reaction that ripples through billions of minds when the truth, whatever it is, becomes impossible to ignore. Because it is not the data that shapes the world, it is the way people interpret it, fear it, embrace it, or deny it. And in that reaction lies the real test not of science, but of civilization. If Atlas proves to be natural, yet astonishingly complex, then humanity will almost certainly respond with wonder. Scientists will speak of new physics. Educators will rewrite their curricula. The public will shift from confusion to fascination as they learn that the universe can sculpt forms so precise, so disciplined, that they resemble artificial structures. But even this version of the story will challenge us, because natural anomalies often force us to confront how much we still do not understand. The revelation would humble us, reminding us that the universe is far more inventive and sophisticated than our current models allow. And in that humility, hope would bloom. A sense that there are still mysteries worth chasing. That discovery is not a chapter behind us, but an endless frontier ahead. But if Atlas begins to behave in ways that cannot be folded into naturalistic explanations, if the jets remain impossibly straight, if the acceleration suggests deliberate control, if the chemical signatures resist incorporation into conventional models, then humanity will face a kind of crossroads we have never encountered before. Not a cinematic confrontation, not an invasion, not a broadcast from the stars, but something quieter and perhaps more profound. The realization that intelligence may not be unique to Earth. And although this idea has floated through human imagination for centuries, its confirmation would still strike with the force of a paradigm shift. Because believing in extraterrestrial intelligence is one thing, witnessing evidence of it through an object drifting silently through our solar system is something else entirely. In such a moment, humanity would divide not out of malice, but out of instinct. Some would greet the revelation with exhilaration, seeing in it the promise of a future where we are no longer alone. Others would recoil, fearing the implications, imagining dangers where none have been demonstrated. Many would cling to familiar beliefs, shaping the revelation to fit their worldviews. And governments would respond with the cautious pragmatism that has shaped every major geopolitical moment in our modern history. Meetings behind closed doors, assessments of risk, debates over transparency, discussions about who controls the narrative. Not because Atlas itself poses a threat, there is no evidence that it does, but because the unknown has always unsettled the halls of power more deeply than the known. Yet beneath these institutional reactions, a more intimate human struggle would unfold. People would ask themselves what it means to be human in a universe where intelligence is not solitary. They would question whether humanity is prepared philosophically, ethically, emotionally to share its cosmic stage. They would grapple with ideas that rarely enter daily life: our responsibility as a young civilization, our fragility, our capacity for unity or division, our readiness to learn rather than impose. And in that introspection lies the true paradox. The possibility of intelligence beyond Earth does not diminish us. It demands that we rise to meet it. Imagine the quiet conversations in homes, in classrooms, in cafes. People wondering whether other beings existed long before us. Whether they faced their own trials, their own wars, their own choices. Whether they survived long enough to create something capable of crossing the interstellar gulf. Whether Atlas is a relic, a probe, a derelict, a seed of knowledge, or something entirely beyond our imagination. And for every question answered, 100 new ones would appear. This is the nature of revelation. It expands the universe faster than understanding can keep up. But no matter how humanity reacts, whether with fear or fascination, one truth remains constant. The discovery of intelligence elsewhere would not rewrite who we are. It would reveal who we have always been. A species defined not by certainty, but by curiosity. Not by control, but by the desire to understand. Not by isolation, but by the longing to connect with something larger than ourselves. And perhaps Atlas, whatever it is, offers us a mirror rather than a message. A reflection of our fears, hopes, ambitions, and limitations. A reminder that knowledge is not given, it is earned through courage, patience, and humility. And so humanity stands before the paradox of choice. We cannot control what Atlas is, nor can we force the universe to align with our preferences. But we can choose how we respond. With openness or denial, with unity or division, with wonder or fear. And in that choice lies the measure of our civilization, because the object drifting through the dark beyond Mars is not simply a mystery to be solved, it is a test of whether we are ready to confront truths that do not conform to our expectations. A test of whether we can embrace understanding without demanding comfort. A test of whether we can grow not through dominance, but through awareness. Atlas will never speak to us. It will never declare its nature or intentions. It will simply continue on its path, indifferent to our anxieties and dreams. But in its silence, It forces us to speak, to ask, to imagine, to reflect. And perhaps that is the point. Not contact, not communication, but confrontation with ourselves. With the fragile, luminous idea that humanity is at the very beginning of its journey, standing on the first step of a staircase that rises through the stars. Whatever truth Atlas carries, the moment is approaching when speculation must give way to understanding. There comes a point in every scientific mystery where the universe stops hinting and begins revealing, where the fog thins just enough for shapes to emerge. And that approaching moment creates a quiet shift inside everyone who has followed this story. Scientists, thinkers, dreamers, skeptics, people who have stared at the images and felt something they can't describe. Because deep inside, beneath the theories and models and carefully measured uncertainties, there is a shared awareness. Whatever Atlas is, it is extraordinary, and extraordinary things demand a certain honesty from us. Not the honesty of certainty, but the honesty of admitting what we truly know and what we truly do not. Humanity is often uncomfortable with the phrase, "we don't know." We prefer answers that are sharp, defined, and unambiguous. But the cosmos rarely grants us that luxury. It communicates in riddles, in patterns, in behaviors that force us to confront our assumptions before it offers us clarity. And perhaps Atlas's greatest lesson is that understanding begins not with explanations, but with humility. To look at an object behaving in ways that contradict our expectations and resist the boundaries of our models is to acknowledge that the universe does not exist to validate our theories. It exists as it is. Our role is not to demand coherence, it is to discover it. As Atlas drifts through our solar system, trailing its impossible lines across the darkness, it offers us a moment to step back from the noise of certainty. The straight jets, the chemical anomalies, the strange trajectory, the brightness shifts. Each one is a reminder that science is not a monument built on answers, but a practice built on questions. And the most honest conclusion we can draw today is the one scientists rarely say aloud. We are standing in front of something we do not yet understand. Not because we are incapable, but because the universe is larger than our present comprehension. But acknowledging uncertainty is not weakness, it is strength. It marks the beginning of discovery, the moment when curiosity outweighs pride, when the desire to understand becomes more powerful than the need to be right. And in this sense, Atlas is a gift not because it offers revelation, but because it challenges us to grow, to improve our tools, to refine our models, to imagine beyond the familiar, to embrace the possibility that the universe still contains mysteries worthy of awe. Some will demand immediate answers. Some will jump to conclusions. Some will fear what they cannot classify. But the measured voice of science reminds us that truth is not rushed, it is revealed. Not in dramatic declarations, but in patient observation, in data, in repeated measurements, in the accumulation of evidence until speculation dissolves into understanding. And soon, perhaps sooner than we expect, that evidence will arrive. Atlas is still moving, still changing, still shaped by forces we have not yet fully mapped. Its story is not finished, and neither is ours. But as we wait for clarity, one truth stands above the rest. The value of this moment is not in the answer we will eventually receive, but in the perspective the question has already given us. Atlas has reminded us that we are newcomers to the cosmic stage, that we stand at the threshold of knowledge far greater than ourselves, that we are only beginning to understand how dynamic, how strange, how elegant the universe can be. And that humility in the face of the unknown is not surrender, it is preparation. So where does that leave us today? Not with conclusions, but with possibilities. Not with declarations, but with direction. Atlas may turn out to be an exotic comet, shaped by natural processes we have never witnessed before. It may turn out to be a relic from a region of the galaxy where chemistry, structure, and thermodynamics operate under unfamiliar rules. Or it may be something built by minds we have never met, following principles older than our sun. We cannot choose the truth. We can only follow it. And that is the point. Science is not prophecy. It is the willingness to walk into darkness with open eyes, trusting that each new piece of evidence will illuminate the next step. Atlas may soon reveal what it is. It may shatter our theories, or confirm our fears, or expand our imagination. But whatever the outcome, the universe will go on, patient and indifferent, offering us one mystery after another. Our task is not to control the story, it is to listen. Because in the end, truth is not something we invent, it is something we uncover. And Atlas, with its silent geometry and impossible behavior, is a reminder that the universe does not bend to our expectations. It invites us to rise to meet it. In the quiet that settles after all theories have been spoken, after every anomaly has been mapped and every model has been stretched to its limit, there comes a moment when humanity must simply gaze into the dark and accept that some truths arrive not as conclusions, but as invitations. Atlas, with all its contradictions and impossibilities, occupies precisely that space. It stands at the intersection of what we know and what we are just beginning to imagine, a reminder that the universe is not obliged to unfold according to the pace of our understanding. And perhaps that is the most important revelation it offers, not a statement about what it is, but a challenge to reconsider what we believe the cosmos is allowed to be. Because long before Atlas entered our telescopes, humanity built its worldview around the idea that the universe is governed by order laws we can measure, forces we can chart, behaviors we can predict. And most of the time, this framework serves us well. It has carried us to the moon, placed probes around distant planets, mapped galaxies shimmering hundreds of millions of light years away. But every so often, the cosmos sends us something that refuses to fit. Something that forces us to confront the borders of our knowledge and the fragility of our assumptions. Atlas is one of those things. Not dangerous, not threatening, just different, so different that it forces us to grow. And in that growth lies a quiet beauty, because when the universe hands us a mystery like this, it is not testing us, it is teaching us. Teaching us that certainty is temporary, teaching us that humility is strength, teaching us that discovery is not the act of finding answers, but the courage to confront questions that unsettle us. Atlas may never reveal its nature with absolute clarity. It may continue slipping through our models like a shape shifting behind mist. Yet even in its silence, it changes us. It reminds us that our knowledge is a thin shoreline against an ocean we have barely begun to explore. And someday, perhaps, humanity will look back on this moment the way early astronomers once looked back on the first telescopic glimpses of Jupiter's moons or Saturn's rings, with a mixture of nostalgia and astonishment at how small our understanding once was. Because this is how scientific revolutions begin, not with certainty, but with tension, with anomalies. with a stubborn refusal of the universe to behave the way we expect. What feels impossible today becomes tomorrow's foundation. What we fear to imagine becomes the reality our descendants take for granted. And in this sense, Atlas is not an outlier, it is a herald. A preview of discoveries still hidden behind the veil of interstellar darkness. Yet even beyond the scientific implications, Atlas leaves a mark on the human heart. Because to confront something so alien, whether natural or crafted, is to confront the limits of our species. We are small, fragile, temporary. We live on a pale world, warmed by a single star, sheltered by a thin atmosphere. And still, despite all that, we dare to ask questions. We dare to observe the sky not with fear, but with curiosity. We dare to imagine futures in which mysteries like Atlas are not anomalies, but stepping stones. We dare to believe that we can understand the universe, even when it sends us riddles we cannot yet solve. Perhaps this is the true legacy of Atlas, not the data it gives us, but the courage it demands from us. The courage to let go of the familiar, to embrace the unknown, to look at a phenomenon that defies everything we thought we understood and say, without shame or hesitation. We are ready to learn, because the unknown is not our enemy, it is our origin. Humanity was born into mystery, born beneath a sky full of lights we did not understand, born into a world whose rules we had to decipher piece by piece. And every time we encountered something new, we grew. And now, with Atlas passing through our solar system, we stand at the edge of another moment of growth. Not because the object offers answers, but because it offers perspective. It reminds us that the universe is not a quiet backdrop to human life. It is a dynamic, evolving, endlessly creative engine, weaving structures and stories across billions of years. Structures that sometimes look familiar, sometimes look impossible, and sometimes look as though they carry echoes of intention. And whether Atlas is a natural product of cosmic processes or something forged by forces we do not yet comprehend, it has already fulfilled its purpose. It has expanded the human imagination. It has pushed the boundaries of our models. It has reminded us that science is not the pursuit of certainty, but the pursuit of truth, and that truth is often stranger, larger, and more beautiful than we expect. So Atlas will continue on its silent journey, drifting back into the vastness between stars, leaving behind data, questions, and a faint trail of wonder across the human story. It will not turn back. It will not answer our questions. It will simply move on, as all interstellar travelers do. But we will remain changed, more curious, more humble, more aware of the vastness that surrounds us and the possibilities it contains. And long after Atlas fades beyond the reach of our telescopes, its lesson will endure. The universe is not finished with us. It is still writing, still revealing, still waiting for us to catch up. And somewhere, perhaps not far from where Atlas now drifts, other mysteries are already on their way, carrying with them the next chapter humanity has not yet learned to imagine. In the end, there is something profoundly moving about the idea that an object like Atlas can drift into our solar system, stir our imagination, challenge our assumptions, and then disappear again into the dark. It is a reminder that the universe does not revolve around our need for closure. It does not tailor its mysteries to our timelines. It simply unfolds endlessly across distances and epochs too vast for any single species to claim understanding. And yet somehow this indifference does not diminish us. It elevates us. because standing beneath the sky, facing something we cannot fully explain, we are confronted not with insignificance, but with possibility. Perhaps that is why Atlas lingers in the mind long after the telescopes stop tracking it. Not because it confirms anything dramatic, but because it leaves room for wonder. It forces us to expand the narrow window through which we view the cosmos, to acknowledge that we may be witnessing processes or structures that operate on principles we have not yet learned to articulate. And in that acknowledgement, there is a quiet thrill, the kind that comes from sensing for the first time that the boundaries of the familiar are beginning to stretch. As humanity continues observing, theorizing, questioning, one truth becomes inescapable. Atlas has already succeeded in reshaping the conversation. It has reminded us that the universe is not a solved puzzle, but an evolving story. A story written in trajectories and spectra, in jets and shadows, in anomalies that refuse to behave. And like all great stories, it leaves us with more questions than answers. What forces sculpt structures like this? What environments give birth to such precision? What histories, natural or intentional, shape a body capable of behaving in ways so far beyond our expectation? These questions may not find resolution today or even in our lifetime, but they point us forward, urging us to build better instruments, to develop deeper theories, to look beyond our familiar frameworks and search for the next horizon. And maybe that is the true significance of Atlas, not the data it brings, but the desire it awakens, the sense that we are standing at the beginning of a long ascent. An intellectual and spiritual climb toward understanding a universe far older, richer, and more complex than the world we evolved to navigate. A universe that will never reveal its secrets all at once, but will always offer enough mystery to keep us moving, thinking, reaching. One day, perhaps, another interstellar traveler will arrive, bearing its own anomalies, its own contradictions, its own whispers from a distant region of the galaxy, and we will meet it with sharper tools, broader theories, and a deeper readiness to understand. When that moment comes, we will look back on Atlas not as an isolated curiosity, but as the first piece of a much larger pattern, a reminder that contact with the unknown does not always come in the form of voices or signals, but sometimes in the silent passage of an object whose behavior refuses to be ordinary. And so Atlas drifts on, vanishing into the expanse from which it came, carrying with it answers we may never hear and questions we will spend generations trying to articulate. But even as it fades, it leaves a mark, subtle yet indelible, on the trajectory of human thought. It teaches us that the universe is vast enough to surprise us, intricate enough to humble us, and generous enough to offer mysteries that ignite our imagination rather than extinguish it. In that sense, Atlas is not just an object. It is a reminder that the cosmos is alive with possibility, that we, for all our fragility, are participants in something immeasurably grand, and that the journey toward understanding has only just begun,